Yes, good evening, guys. Good evening, everybody. How are you all doing? Great, great. Good evening. Yes, amazing. Yes. We'll just give a few minutes to for people. And once the room is full, we should begin. Okay, I think we can begin now. Just share the screen. Yeah. So, guys, quick recap before we begin the session, so that we can ensure that everybody is here. Before everybody is here, then I would just like you to give me a recap of what we learned yesterday and and what did we actually infer from whatever we learned yesterday. Yes. Who's going to tell me that? Who's going to tell me what we learned yesterday? Okay, we learned about ML workflow and what happens in an ML workflow. What are those steps that takes place in an ML workflow? Yes. What did we learn in ML workflow? Hey guys, come on. What happened? You did not have dinner, or you're about to have, so you all are hungry and not able to answer. Hmm? Data collection, pre-processing, model training, performance analysis, deployment, and evaluation. Sunita, you messed up the order a little, but yeah, no worries. Data collection, pre-processing. First is strategy, right? First strategy. Then you collect your data, then pre-process the data. Then data modeling, training, and evaluation. Right? Evaluation does not come in the end. Training and then evaluation, testing. Then you have your deployment, performance monitoring, optimization. Right? So optimization is the process before deployment. You optimize the model, then you deploy, then you monitor the performance. Then, if your performance is not good, the feedback will be sent to the optimization again, and the optimization will optimize the model so that the model can be optimized for the feedback also, right? Once the feedback is proper, once the feedback is good, it means your model is ready, and now you can launch that model into production, right? What is production? Production is the place where you try to deploy the model into the market, right, as a software. So you package the entire model and you deploy it as a software. Right, so these are the things that we saw, and after that we also had a look at the machine learning engineer, right? What does a machine learning engineer do in their day-to-day life? Right, so it is an entire pipeline of processes, right? So you have data pipeline, ML pipeline, and you have the software code pipeline. So I'm not going to repeat the entire process again, but yeah, I hope you all understood what this entire machine learning engineering is all about, because this is what exactly a machine learning engineer should know about. Okay, so one by one we will start. with whatever is necessary to become a machine learning engineer, and then we will progress further. Okay, so first part is your data collection, exploration, and validation. So we will first look into the data pipeline, then we will slowly transition into the machine learning pipeline, and then into the software code pipeline, and then we will see an entire project on how to deploy a machine learning product as a whole. Okay, so we will look into all of this, and once that is done, then we will move on to our next phase of deep learning. Or let's see how entire thing plans out, and we will schedule. Okay, so yes, so beginning with our data pipeline today. Okay, our first and foremost, the first step, right, to make sure that everything is properly like trained, everything is properly fed into the algorithm. We need to have the data set properly in place. So if you don't have a data set, what will happen? Definitely, you will not be able to build your ML model. You will not be able to train your algorithm. You will not be able to create rules, and everything after the data collection part cannot be done, right? So for making sure that you have a machine learning pipeline, you have a software code pipeline, you have to have the data collected first, right? So the first process that we will see is nothing but the data collection, and data collection is the part where we are collecting the data from different sources. Okay, so by the end of today's session, we should be able to uh, set up in a working environment for ML, okay, which obviously will not touch the practical right now because I don't want to mess up things. So that I want everything to be clear first, and then we will slowly transition into the whole practical session. Okay, right. So the first thing is we will be able to set up our ML workflow environment or ML working environment. Second thing is we will understand how actually Python plays a very important role and fits into our ML cycle, right, ML life cycle. Third thing is we will be able to load the data and we will be able to inspect the real time data. So we will learn this as well as we progress. Okay, and finally, we will also see some errors that more commonly a user faces or a student when they try to do ML projects and stuff. They face this a lot. Okay, so we will see these errors one by one. We will see how we can solve those errors and why those errors occur. So that this will give you an overview of whenever in future you work on any ML problem statement or anything, you will realize that okay, this error happens because of this. Okay, so for today, our goal is set, right? We should be able to set up the ML working environment, correct? Okay, then what else should we be able to do? We should understand how Python fits into our ML lifecycle, correct? Third thing is nothing but we should be able to comfortably load data and inspect the data. And finally, we should be able to solve the errors that occur while setting up the environment for ML workflows. Okay, so we will begin with this entire thing. So that hence today's entire topic is nothing but Python and ML environment bootstrap. Okay, so it is nothing but Python and ML environment bootstrap. So don't worry about this. All of these notes, I will write some more sentences. I'll put some more inputs, and then I will create an entire document. And this document I will give you as a link so that you guys can it in the drive. Okay. Just give me a moment. Let me set. So yeah. So these are the four things that we should be able to understand by the end of our lecture. So let's start with why is Python necessary for ML? So once we understand why Python is necessary, then we can move on to the dataset part and understand how to load the data, how to inspect the data. So okay, so yes, all right. So see, why do we use Python is because Python has four different features that ML needs from a particular language. Okay, so now if you use Java, if you use C++, if you use these kind of languages, they might not be able to give what ML needs for the workflow or for their life cycle. Correct. So this is why Python dominates in this field of ML. So why does it do? Because Python has four features, okay, which is very much required by a ML lifecycle. What is that? First thing is your fast prototyping. Okay. Now, what does fast prototyping mean? Prototyping means that you will be able to develop a version, a dummy version of the final product very fast inside Python. Because Python gives you a lot of freedom to use different libraries and different modules that make sure that you can build a dummy model before you actually start with your actual product or an actual ML model. So this is the reason why Python has dominated in ML because of this first feature, which is fast prototyping. Okay, second thing is that it has a rich ecosystem. Now, what do you mean by rich ecosystem? Means it has a lot of resources. So Python has a lot of resources for ML, for building ML models, for constructing ML pipelines, constructing ML workflows, right? So that is what we mean by rich ecosystem. Third thing, which is very important, is nothing but human readable logic. Now, what do you again mean by human readable logic? Very simple to understand. Is that you as a person, even if you don't have a lot of experience coding, right? If you look at a Python program, you will automatically understand some concepts. It's not like obviously you will understand in depth, but when you look at a Python code, you will feel like okay, this is just English, but in short, written in short. Okay, so basically it says that Python is a human has human readable logic, which means any human who has little bit understanding of programming language or little bit understanding of programming as a whole, they'll be able to understand the code that is written or the logic that is written in Python. So that is the reason why Python has dominated over ML because ML looks very easy when Python is you know, in action. Then you have something called as community tested libraries. Now, what are these community tested libraries? These community tested libraries are nothing but modules that are present inbuilt in Python, right? Which make sure that you have the particular resources for building an ML model. Now, for example, if you're building something related to, let's say, again, let's take the same example of a loan approval system, right? If you're doing that ML model, then you need a data frame, correct? You need some variable that should handle the tabular values of the entire data set, correct? Because data set can be in the form of anything. It could be in the form of file, it could be in the form of a database, cloud resource, anything, right? To handle those kind of data sets, we need some, data frames, or we need some kind of variable or object which can hold that value inside, right? So Python has a lot of different community test libraries which are used in ML. One such example is pandas. One such example is NumPy, right? So these are the libraries which allow us to leverage the entire ability of having the objects that can store the values, and hence it will be able to create objects that will contain the data set value. Okay, so that is the reason why Python is dominating in this field, and this is the reason why other languages have not yet come across this concept of ML. This is the sole reason because other languages don't have a human brain. Now, if you go for Java, Java has a very complicated, machine. It's like a machine level language logic. So that is the reason why Java is not yet there in the ML field. So that is the reason why Python is being used because it has a human readable language. And then community tested libraries. A lot of different libraries that are there are developed in Python, which gives us the capability of building an entire ML, right? So the thing is that Python is considered as an operating language. Operating language. Now, don't worry, I'll not be teaching you about Python because Python in itself is another topic, right? It's another subject. So we will not touch a lot on Python. Whatever concepts are there that I need you to know, I'll be introducing it when we start our practical session. That is when you will come to grasp all the Python skills. Okay. So yeah. So today we don't. So the thing is that today in this modern times, we don't build intelligence, right? We just prepare the factory where the intelligence will be built, right? So whatever we do using code, using Python and stuff, right? It's not we're not building any kind of intelligence. Okay, make sure that you keep this in mind because it's a very important thing that you know. So using Python, you're not building intelligence. You're just building a place or a factory where the intelligence can be built or will be. So this is the reason why Python is considered as a very strong language for prototyping as well as for ML lifecycle. Okay. So now let's move on to how actually we can set up a particular Python environment in a Jupyter. Okay, so obviously we will be using Jupyter Notebook or Collab for these purposes, and usually we'll use Collab because Jupyter Notebook might not give full capabilities that Collab gives because there are a lot of different things that Collab offers, which we will discuss in another session when we are moving on towards the practical. But right now we will just see how exactly an environment of ML looks like. So machine learning environment, how does it actually look like? Okay, in the professional field, in the industrial field, how does an ML model uh, look like? How does it have to be designed in order to become industrial? Okay, so now we will have a quick overview of this ML environment, how we start building this entire environment. So first thing is that you need to have a data set, correct? So the data set can be from anywhere. Could be a file, could be a CSV file, could be Excel, could be cloud resources, could be anything, literally. Then you have the file browser, which has your entire browsing history where you can browse all the files that you require. Okay, so whenever you are constructing a project structure for ML, make sure that you have three things in your project structure. Okay, what are those three things? First thing is definitely a data set folder. Okay, because why am I specifying about the project structure is because once you have built your project structure, your 50% of your job is done. Okay, the professional standard that I'm talking about, the 50% of the standard comes from your project structure, how you build the project structure, right? So in order to build the project structure, you have to make sure that you are making different folders in order to collect the data and store. Okay, so you have the dataset folder. So inside the dataset folder, you will have maybe the train dataset, test dataset, whatever dataset you have collected. Maybe raw data. Maybe there is no training and testing as of yet. Maybe you will do it later. So whatever is there, everything should be stored under a single dataset folder. Then coming to the main code, okay, main code or main.py, or usually we use notebooks, right, for ML model. So IPYNB. Okay, so IPYNB is nothing but the extension for storing the Python. Okay, and main.py is nothing but a Python file. So the difference between Python file and Python notebook is that the Python notebook gives you a line by line execution opportunity, whereas main.py, which is a Python file, executes the entire file as a. Well, these are the two differences between your Python notebook and Python file. Now, how to choose what to use, when to use? Now, when you're using a Python notebook, okay, notebooks, so guys, very important. Okay, always remember that notebooks, okay, notebooks are used for demonstration purposes or dummy models. So when you're using a notebook, right, a notebook of notebook format, okay, yeah, when you're using a notebook format, okay, you have to make sure, you have to understand that a notebook can only like basically give you a demonstration of a ML model. You cannot build the entire model inside of it. Okay. So guys, see, from tomorrow I will not accept students after 8:20 because it's a disturbance. So please make sure that before 8:20 you are all in the class. Okay. Yes. So what I was saying is that a Python notebook always gives you an entire overview of how the ML model has to be actually built. Okay. So you're not actually building the entire ML model. Okay, whatever you're doing is your training part. You have uh, built an ML model which is giving an accuracy which you required. But when you want to transition from that ML model to an actual model which can uh, hold a lot of data, which can which can take a lot of input data and train it and give an output. Right? That is where you switch your file from a Python notebook to a Python file. Okay, so why do we do that? Basically, is because a Python notebook cannot actually process the entire thing. So you can't build an entire pipeline inside. I mean, your entire workflow inside Python. Okay, so what are we doing is basically we're taking a Python notebook. Inside the Python notebook, we are only doing everything related to the data. Then we are training the model, we are saving the model, and that saved model, when you want to go an extra level, when you want to optimize the performance, when you want to do something more, you want more inputs to come, you want more data to be taken in. What you will do is you will transition from a Python notebook to a .py file, which is nothing but a Python file. Okay, so this is the difference. There is a major difference between a Python notebook and a Python file. Now, your question might be why is this a difference? Like, why is not both the things same, but only the extension format is different? Okay, I'll tell you why. So the thing is, in Python notebook, okay, you do all the experimentation. Okay, so Python notebook initially was built, a notebook was initially built just to store all your experimentations that you do on a particular ML model or related to an ML. Whereas in Python file, you don't do experimentation. Okay, you write the main logic. You write the main logic that is taking the Python or the ML model as a entire model. So you are not training the model inside the Python file. You are just taking the saved model from the Python notebook and you are using it for your various purposes. Now I'll give an example which will make it everything very crystal clear. So consider the example that let's say I am building an ML model for um, okay, for maybe handwriting recognition. Okay, maybe I'm building an ML model for okay, not handwriting recognition. What can I give? Classifying whether an email is spam or not. Okay, let's take that for an example. Now we have the numerical data. Okay, which is given in your data set. Now that data set you are going to use as training data and testing data, and you are going to build the ML algorithm and you are going to train it. Finally, you are going to evaluate. Correct? Once your evaluation is done, you will feel like, okay, now that I got the evaluation, maybe I can improve the accuracy. Correct? You will go back, you will try to train the model in using another data set, maybe another data set split, which is nothing but 60-30, 60-40 or 70-30 or 80-20 or whatever you want to take. You will do that and you will see that, okay, now I'm getting a better accuracy. Now you will keep on experimenting inside the notebook, okay, and you will finish doing it, you will finish executing each and every line, and finally you will come to a conclusion that, okay, now this model is perfect. I don't want to make any changes here. Now let's deploy this model. Now for deployment process, you cannot deploy it inside your Python. Why? Because Python file and Python notebook are running on two different kinds of interfaces. Okay, now, whatever interpreter you are using in a Python file may not be able to use in your Python notebook. For example, uh, maybe you cannot run some library called as there's a library called as Kindle. So usually, when you want to make interfaces for your ML models or your data models, you use this library called as Kinter. It's called TKINTR. So this Kinter is a library in Python which provides a UI, a graphical user interface. So before, this graphical user interface did not work in your notebook. Now I think they have changed that. They have updated some change. They have made some changes in the environment, and they have made it able to run in your Python notebook. But before, it did not run in your Python notebook. It used to give some kind of error. But in the Python file, it used to run smoothly because the Python file had more capabilities than a notebook. So the point I'm trying to make is that there might be some libraries that might not run on the Python notebook, which you require, okay, but might run in your Python file. So that is the reason why we choose Python to make sure that whenever you are finished deploying a model, then you will go with your Python. Okay. So, okay, somebody asked a question. Why don't we use collab? Yes, yes. So, Holifa, I think you just joined now. So, I made sure that I explained people that we will be using Google Colab itself. We will not be using Jupyter Notebook. This is only for explaining you the bootstrapping process, for explaining you the project structure. Okay, so don't worry about all of that. I'll take care of it. Here, right now, we will just try to understand the professional grade, the professional, the industrial standard. So this is something that you will not be aware of. The industrial standard is very important when you consider an internship. Okay, so that is why I'll be taking it from an industrial perspective, and then we will move on slowly into the practical session, which we will do in collab. Okay, so in collab, we will be doing our ML training and all of that evaluation. Then we will store the ML model, and then we will move on to our VS Code, where we will use that ML model and we will create our entire software. Okay, so we will see everything in detail. Don't worry about it. All right. So what I was trying to say is that yeah, when you do an experimentation, you are always going to use your Python notebook, and whenever you are done with your experimentation, and you're satisfied, then okay, this is my model, this is ready. You can then save the model and then proceed with the Python file. So in the Python file, you will mainly write the logic. So anything related to logic will be written in your Python. Okay, so Python is going to the Python file is going to have your code, whereas in a Python notebook, okay, on the notebook code, the results that you get in the notebook or the execution part that you do in a notebook is having a specific format. Okay, so that specific format you can only run in a notebook. So that is why we use notebook differently and we use Python file differently. Okay, another very good difference is that Python file is mainly used for server side processing. Now I will now you might ask me, so what do you mean by server side? Do you mean building a server, or do you mean constructing a server where I can do the server side logic? Yes, that is what exactly I mean. I mean by server side, I mean that the Python file stores the logic related to the server. So whatever code you are going to run on the server is going to be present inside your Python file. It cannot be present inside the notebook file. So this is one major difference that nobody will tell you. But Python files are mainly used for running server-side logic, whereas Python notebooks are only used for writing a particular part of the code, which is nothing but your ML model or your data model or data analytics or NLP model or anything like that. Okay, so you are not actually doing the processing part there. You are only doing the model building part. That is the difference between your Python notebook and your Python file. Okay, so moving further, yes, then we have our relevant formulas, then we have our visualization concepts, then we have our saving part, right? So first we consider having our dataset folder, then we considered having our main.py, and then finally you will have your output directory. Okay, so first is your dataset folder. What does the dataset folder contain? It contains the dataset. So the dataset you will be separating it. So dataset is separated and filtered. Okay, this one py file for server processing or server code processing and nb for model building purposes. Then finally, the output directory is where you will save the model. So whatever model you build in your Python notebook, everything will be saved inside your output directory. The output directory could be a folder, could be a single file, could be anything. It's totally up to the user what they're trying to do, what they're trying to build. So if I am just trying to build a single ML model, I will just keep a single file. I don't have to build an entire output folder. I just have to save the single file and I have to keep it there. But if I am working on multiple ML models, let's say I am working on a loan detection, a loan approval system, I'm working on some kind of classification model, okay, and I'm working on another kind of model. So these three different models will be stored in three different files or three different directories. Okay, so that is why we are having this structure in our ML. Okay, so this is a very basic workflow, right? This is only for the ML part. Remember that we are not yet come to the entire software code pipeline. That will be a very long thing. That will be a very long code. But this is how you construct your basic ML directory. Okay, basic ML project directory. Of course, there are a lot of other things that we will definitely see one by one. But for now, you should understand that this is how your actual ML workflow or project structure should be. So once you have this project structure ready, it means your ML workflow is also partly ready. 80% of your work is done. The rest 20% is nothing but where you create where you become creative and you use the concepts of classes, objects, functions, and all. So we will see that once we are done with our entire overview of the setup and overview of our industrial project structure. Then we will come to how to set up this actually in your VS Code or whatever IDE you use. So far, any doubts, guys? Any doubts regarding anything? Hopefully, no doubts because it's very straightforward, right? So yeah. So now we will come to our Python libraries that we are going to firstly use. First libraries that we use for our data is nothing but NumPy and pandas. Okay, NumPy also we will use later on, but first thing that we should know is pandas. Okay, now why do pandas exist? Why do NumPy exist? So NumPy is nothing but your numerical Python, which is nothing but a numerical computation engine. What is NumPy? NumPy is your numerical computation engine, whereas pandas is your data handling and analysis, right? So pandas is a library, is a very important library, I would say, in ML because it consists all the data handling parts and all the analysis layers. Okay, down the line we will see how to do all of the analysis because we are going to see all of these processes, right? We're going to see all of this process of the workflow. So right now we are only in the data pipeline stage. Then we will see our exploration, we will see our wrangling, cleaning, data versioning, all of this. Then we will enter into our machine learning pipeline. Then we will see entire software code pipeline. So we have a long way to go, right? But trust me, it is going to be very easy once we enter sequentially. Everything will be starting to become very easy. Okay. So yeah. So NumPy and Pandas are the two libraries that we are going to use. Now you might ask again, why only NumPy and Pandas? Why can't we use Python's inbuilt data structures? Yes, you can use Python's inbuilt data structures, but Pandas and NumPy are not only data structures, it also gives you abilities to create multiple objects for storing the data. It has multiple operations that you can perform on data, right? You have statistical analysis that you can do on data. You have information collection. You can describe the data, right? You can get the number of columns. You can get the number of rows. There are a lot of different things that Pandas and NumPy offer regular than your regular data structures, right? That is the reason why we use pandas and numpy instead of using your regular data structures. Okay, so take the analogy of numpy as your Excel formulas. So you know how Excel formulas are written, right? So Excel formulas are nothing but numpy as a whole in Python. Okay, whereas pandas is not your Excel formula; it is more about your Excel sheets or your filters that you create in Excel. So I hope everybody knows what Excel is, right? So yeah, your Excel sheets, your filters, your pivots, right? Your funnels, all of this is nothing but your pandas. So as I told you, pandas not just offers a place where you can store the data, right? But also offers a lot of operations that you can perform on. Okay, so in general, a pandas data frame usually looks like this. Yes. So a pandas data frame, okay, a pandas data frame usually looks like this. You have rows, you have columns, okay, and each, one second, let me just admit, and each row contains different objects, right? That is nothing but your pandas data. Then you have your numpy array. So now what is the difference between a numpy array and a pandas data? Who is going to tell me this? Yes, who is going to tell me what is the difference between a numpy array and pandas data? Yes. What do you observe? What do you see the difference between a pandas data frame and a numpy array? Yes, guys. Okay. So the first difference, okay, please remember this. The first difference is that numpy arrays can be multi-dimensional. Okay, whereas data frame can never be multi-dimensional. It can be only two-dimensional. Please remember this. Okay, data frames are only two-dimensional data structures, and numpy arrays are multi-dimensional. So it can be more than two-dimensional. It can be two-dimensional. Okay, then second difference is that arrays contain similar type of objects. You know this. You know the definition of array, right? What is it? Collection of objects of similar data types. Whereas in a data frame, you can notice that you will have different kinds of objects. You can have integer, you can have datetime object, you can have character, you can have float, anything. But in here, you will see you have only character. In some cases, you might have only integer. In some cases, you might have only float. Right? So arrays only contain similar types of data. I think this is very important that you should know. Arrays contain similar types of data, and whereas data frame contains only 2D. Okay, this is the first difference. What about the second difference? What did I tell you the second difference is? Arrays can be, numpy can be, sorry, what did I write? Contains different types of data. I missed the second part. Yeah. NumPy arrays can be multi-dimensional, correct? But your whereas data frame is only two-dimensional. This is your second. Okay. What about the third difference? Anybody? Anybody who found out a difference? So this difference is more mainly related to. It's not related to the data, but it's related to the entire structure of it. Who's gonna tell me that? And there is one similarity also. Yes, there is one similarity also. What is the similar? Tell me the similarity and tell me one difference. Okay, forget about the difference. Difference is really complicated. What about the similarity? What do you see is similar between a pandas data frame and a numpy array? Yes. Rows and columns. What do you mean by rows and columns? Gautam? Oh, no, but in numpys also you have, right? You have rows and you have columns. Timestamp, no, sorry. I'm not talking about the see guys. You're getting confused, I guess. Not this data frame and array. I'm just talking about generally, what is the similarity between data frame and numpy? Similarity. Just tell me the similarity. That's it. Then we will discuss about the difference. Null values. Okay, null values. No, but arrays also can have null values, right? It can have a zero value, right? So zero is nothing but null. Okay, the similarity between data frame and numpy array is nothing but both are mutable. Both can be changed, right? A numpy array can be changed, right? We can enter an object, we can remove an object, correct? Whereas in a data frame also, you can change the object. If you want to delete j, you can delete j from it. If you want to delete the whole column, you can also delete the whole column. So pandas data frame and numpy array are both mutable. That is the similarity. So this is one such similarity that we. What about the difference? The difference is where people uh, don't realize. So the thing is that data frames, the data frames that we have, okay, are in the form of SQL tables. So this is where your professionalism or your industrial knowledge comes. Okay, so to understand a data frame, you can take the similarity of it between an SQL table and a data frame. So you will notice that an SQL table also has rows and columns, and your pandas data frame also has a row and column, right? But it is more like an SQL table structure. Whereas in the arrays, okay, we have data associated with numerical data and computation. So whatever we store in arrays, in numpy arrays, are all related to computation and numerical data. Okay, so obviously here also we have tabular data. It is not a flat data structure. It is also tabular data, but the data that we have is mainly related to numerical and computation. Whereas in data frames, we have SQL tables because SQL tables can contain anything, right? Can contain the name of a person, can contain the age, email, anything, right? Any data type. Whereas in NumPy arrays, we cannot keep any data type. We only need to have a one single data type, right? So this is the reason. This is the one such difference that is keeping a professional grade between data frames and NumPy. Then we have another difference which a lot of people overlook, which is that when in an array, right, in an array, when you are accessing the elements, how do you access the elements? My question is, how do you access the elements in an array or a matrix? How do you do it? What is that term that you call for accessing the elements? Index. Very good. So in an array, we use index for we use index for what? For accessing the position, right? Position of the data. What about your data? What about your data? In a data frame, obviously, we are going to use both index position as well as integer, because in here, when you consider a data frame always has an index, correct, and a position for each column and row. So not only we use an index, we also use a integer position. Okay, we use integer and index position for accessing the data. Okay, these are your differences between a numpy array and a pandas data. So this is very important for you to understand because a lot of people I've seen personally, when I've trained a lot of students. So I've seen that a lot of students use arrays instead of data frames. And then I ask them like, why do you choose an array instead of a data frame? And they say that array is easy to access and easy to understand. But Then I asked them a question where how are you going to perform operations? It will be complex, right? Because we are using high computation in arrays. Whereas in data frame, you don't have to use high computation. You already have inbuilt libraries, inbuilt methods, inbuilt functions. Use that, right? Simple. That is the reason why this is very important for you all to understand the difference between an array and a data frame. Okay. Right. So concluding between your data frame and pandas, I mean NumPy arrays, you will identify that a data frame can deal with dynamic data. What does dynamic data mean? Data that keeps on changing and mixed data types. Correct? So a data frame has mixed data types. Right? But what about an array? Arrays do not have the flexibility to handle such data. Okay, a data frame can deal with any kind of data. It can be dynamic, it can be static, it can be mixed data types, it can be single data type, it doesn't matter. But in arrays, it does not have that flexibility to handle multiple data types or dynamic data. Okay, so these are the you could say five main differences and one similarity between NumPy arrays and pandas data. Now we can move on to our further topics, right? Which is how exactly do you load a data frame inside a Python environment. Okay, so the function or the inbuilt method that we have to convert any kind of file, okay, a CSV file could be an Excel file, right, could be some other kind of data. We have some inbuilt methods to convert those data into a data frame, and we have some functions that can convert the data frame into those files. For example, if you have a data set, you will use a function called as load CSV. Correct? So you will use something called as load CSV, which is nothing but your function to load the data set. Second thing is, what if you have a data frame? Okay, you have a data set. What if you have a data frame? Okay, which is stored in an object, and you want to convert the data frame into a CSV file? How will you do that? By using this function called as toCSV. Okay, so we have load CSV, which will load the data, load the CSV data, and toCSV is something that will convert the function to convert the data frame into a CSV format data. Right? These are the two different methods that we will use to load the data set as well as convert a data frame into a data. Okay, so there are two different cases, two different cases. In two different cases, you use two different. Now, my question to you is, why do we have two different methods? Why do we have two different? Why do we have load CSV and why do we have toCSV? Obviously, the functionalities are different, correct? But what is the use case behind having load CSV and having toCSV? Because you might have a question in mind saying that if we have a function called load CSV, then why do we have a function called toCSV? Right? Because our ultimate goal is to load the CSV file into our Python environment. So why do we actually have a toCSV? Yes, yeah, that's what. So since we have a load CSV function, why do we have a toCSV? There might be a question, obviously, because even when I started learning data frame, pandas, and everything, I was like, okay, load CSV is there, but why do we have toCSV? Why do we want to convert a data frame into a CSV file? Right? So this is something again that nobody will tell you, but load CSV is where you start loading the data, the CSV data into the Python file or the Python environment, and then you start storing that data into a data frame. Correct. Now, why do we use toCSV is because let's say tomorrow you're working in some company, okay, and that company is like good work with the data frame, and you have created the data frame, you have um, performed the operations on the data frame, you have created the ML model, everything is done. Now, in the end, the company is like, uh, let's say you deleted the, okay, let's take this scenario. You deleted the CSV file. Okay, you have deleted the CSV file. Now that raw CSV file that you had, okay, to understand the difference, guys. In load CSV, we have our raw CSV file. Right? So here we use our raw CSV file. So this raw CSV file might have lot of missing values, might have lot of junk values, might have lot of values that we don't even require. For example, some data sets they have index, then they have serial number. I mean, why do we need index and why do we need serial number? That's of no use, right? Where are you going to use the serial number? Where are you going to use the index? You're not going to use it because a data frame already has an inbuilt index, right? So that is why we have these two different functions. So what happens here is when you are using load CSV, we have the raw data. This raw data set is the one which can have any kind of value. Okay, it is not a structured, I mean, it is not a clean data set. It is not having complete values. It has missing values. It has junk values. It has some unnecessary columns. Correct. It has some columns that are required, but also you need new columns like feature engineering. Correct. So this is why we have another function called as 2CSV, where 2CSV will store the data frame which has the cleaned data set, cleaned data. So this is why we have load CSV and we have 2CSV. Okay, so load CSV will load the raw data set, right? Raw data set is where you have missing data, you have junk data, all of that. But in 2CSV, whatever data set you have cleaned from this raw data set, right, will be stored in a CSV file. So next time, let's say you deleted that Python file, but you have the CSV file, you don't have to go through the entire pre-processing, entire cleaning, entire transformation, entire operations, right? You can simply use your 2CSV clean data set, which is the final data set. Your entire data pre-processing options are same. Now, did you understand why we have two different functions called load CSV and 2CSV? Yes. So load CSV stores the raw CSV which has maybe missing values, a lot of different values, but 2CSV will always store the clean data. That is the reason why we have this 2CSV, so that if in case in future we lost our raw data set, we have our clean data set which will save us hours of data cleaning, hours of data pre-processing, and hours of data extraction. Okay, so that is why we have two different functions, load CSV and load CSV. Okay, so yeah, then we have what do you call parameters. Yeah, you have specific parameters in different functions. Okay, now for example, when you're loading the CSV file, some CSV files when you go to Excel, okay, when you go to Excel, you will notice that when you're saving the file in your folder, in your file explorer, you will see you have different formats, correct? You will have CSV, you have UTF-8, you will have UTF-8 delimited, correct? UTF-8 comma separated, right? So these are different formats of the same file. Now, you might think, okay, fine, but how is this relevant to our data frame concept? What happens here is sometimes your raw CSV which is downloaded or is installed in your system, okay, it might have the UTF delimited comma separation. Okay, so what happens here is normally a CSV file is separated by commas, but when you use a UTF-8 file, okay, sometimes there are some characters that are not readable by the pandas format. So if you just write load CSV and you enter the file name, let's say that CSV file is UTF-8 encoded or delimited, the pandas function will not be able to read it. Why? Because it has this whole UTF-8 delimited feature, right? So to remove that, we have some parameters in your function, in your load CSV function, wherein you will write load CSV and you will write a custom delimiter where you will give the default as comma. So you have a value like delimiter, and this delimiter the is going to give you the entire data frame as it is in the CSV. So it is not going to consider the comma values at all. So this is why we have some custom delimiters in the CSV. So moving further, we will see all of those delimiters as well, how to exactly do that. Because moving on, once you enter into a company, and you will get files which are delimited, which are having UTF-8 encoded. So that is why it is very important for you to know what a delimiter is. So delimiter is nothing but it removes those special characters from the CSV file. Okay, and then we can also specify the columns to be used for CSV output. So basically, when you're storing the two CSV, when you're storing the CSV file, when you're creating the CSV file from the data frame, you have something called as specifying the columns. So you can specify what exact columns that you want in the CSV. Maybe you don't want to store all the columns in the CSV file. Maybe there are 100 columns and you want to store only first 50 of them. Or maybe specific, like maybe just the name, age. I'm just giving an example: name, age, sex, email, contact. Okay, maybe you're just wanting to store that information. So you will only specify those columns that can be stored in the CSV. So you also have that capability inside your inbuilt function. Then you can also ignore the header row. You can ignore the column names. Let's say tomorrow you just want the data. You just want the data. You don't want the. You just want the clean data. You don't want the header names. What are the header names? The column names, right? Like name, age, email, right? So you let's say you don't want that. You can also ignore those column names in the CSV by using this through CSV function, and inside this you will have to specify a parameter. Then you can also ignore the index, right? So there is an option where you can set the index. You can write set index is equal to false. So that will automatically remove the index from the data set. Otherwise, if you just load the CSV file, you will see that the index values are also stored along with the CSV data. Okay, so we will see all of that moving on further. And then finally, there is an option to even specify the string for missing data representation. Now, what do you mean by missing data representation? Anyway, yes, what do you mean by missing data representation in a 2CS? Yes, if you have no idea, it's fine. You can just mention that you don't have an idea about it. The missing data representation is nothing but the missing values, right? Correct, Gautam. Incomplete data. So the incomplete data that you have in your CSV file, you also have the option to specify whether you want that missing data representation or you don't. Okay, so by default, it will be stored as an empty string. If you don't want that missing data representation, you can simply add a parameter which you can mention to remove that missing. Okay, so hope this is clear. And the command for installing the library is nothing but pip install pandas. Okay, so this is your library pandas, which allows you to do different things. Obviously, there are a lot of different things that we are going to see later on, but this is something that you should know as a beginner when you start learning about the professional side of. Okay, then after you have loaded the data frame, then you will come across the first process of data inspection, or you could call it as exploration, which is nothing but data inspection. Okay, now we will move into data exploration. Basically, this is nothing but your data pipeline. This is the first stage, right? Data pipeline is the first stage. Data pipeline. And inside data pipeline, the first thing that we will learn is data exploration. And in data exploration, first thing that we have is data inspection. So now what does data inspection do? It just inspects the kind of data. So what are the three different things that comes in inspection? So the first thing is the shape of the data set. Shape of the data set. Like for example, how many values are present in the data set. how many rows and columns? 50 into 50x 100, 50x 2, 50x 3. This is nothing but the shape of it. Then it will show you column names. So you can inspect the column names. And you can also inspect the basic information which is present inside the data frame. Okay. Now, coming to why actually this entire thing matters. Why this matters. Okay. So, since we are learning about data inspection, why exactly does inspecting the data matter a lot? I mean, inspecting the data, you can also do it in the CSV file, correct? Right? You might have the question that, okay, we can also do the inspecting part in the CSV file. So, why do we have to inspect the data again in your Python code? So, what will this do is that this allows you to understand three different things. One is data size. What will data size do? It will allow you to choose a model of your choice. When you see the data set, when you see the data set, obviously, since we have the understanding, right, we have a good processing power. Just by looking at the data set, you will understand what my target has to be. Okay, now for example, in your loan approval system, what is your target in your loan approval system? Whether you have to give the loan to a person or not, right? What is the target? Yes or no? So automatically you know that there are only two things that you need to predict. One is yes, one is no. So automatically you will understand what model I have to use. I have to use a linear regression, right? Or maybe I have to use a normal classification, a binary classification, right? So this is where it matters, and this is why it actually matters. So data size is considered as very important. Then when you find out the basic information, when you print down some values, you will find that there are missing values. So again, this can also be checked in your CSV file, but in the CSV file, you have thousands or 10,000 or 1 lakh lines of 100,000 or millions of lines of data, correct? Rows of data. So now sitting down manually and searching the entire missing values is just stupid, correct? When you already have a way to do it inside Python, then why do you have to see the data set? So obviously, Python also provides you the missing values, okay, which will allow you to understand how to pre-process the data. So this helps in pre-processing of data. Then finally, we have the data types. So when you look at the information, when you do the data inspection process in Python, you will understand that there are some data types which you can use to encode later. Now this encoding part, please don't worry about it. We will come to it later. Okay, so this is something which we will come to it later. So just to give a heads up, we have two types of encoding that we will discuss. One is one-hot encoding and one is multi-hot encoding. So these are the two things that we will discuss later. So this is where your data inspection actually matters a lot. Okay. Then you have your so second step is where you will pre-process the data. Okay. So in data pre-processing, what do you have? You have different steps. Handling missing values, filtering columns, applying logic, applying business logic. Right. So I will just write it down. So what are the different things that are there? First thing is handling missing values. Missing values. And what can you do? You can fill empty values. Right? Fill empty values or compute empty values. Then what about the next thing? You can perform operations on data using numbers, right? Then there is another use case where you can also, so instead of performing operation, you can also filter the columns. Filter the columns. Filter the columns is where you will choose which columns you need for your model, right? So you can so this is where the data modeling process comes into. This is your data modeling stage. In the data modeling stage, we are just building an entire logical model, right? So here another thing could be applying logic. Okay, this could be business logic or numerical logic. Could be anything. Business logic or numerical. But okay, so these are the different steps that comes under data pre-processing. So once you finish pre-processing the data, then we can move on to the next stage of our pipeline or our workflow rather. This is nothing but training and evaluation, right? So data modeling also comes under data pre-processing, but you can take data modeling as a separate stage, right? We will discuss data pre-processing and data modeling together. Okay. So tomorrow in the upcoming session, we will see how to do data collection. I mean, data collection, we will just collect, we'll just try to go over the internet and collect some raw data from the internet. Then we will see how to inspect the data, how to pre-process the data, and how to model the data. So this stage of your workflow will be complete by tomorrow. Okay, so we will see all of this in practical, how to do it. Then we will move on to training and evaluation, optimization, deployment, and then we will see all of this in live. And then finally, we will go with performance monitoring, and then we will see how the entire workflow can be orchestrated. Then we will slowly transition into our ML pipeline, software pipeline, and option. Okay, so that's it for today. Uh, this much should be very clear to you all because this is very important from a ML standpoint, right? So you might think that okay, this is a very small step, but no, this is actually the biggest step before you finish your, before you decide what model you want to do. Okay, so it is very important that you understand all of this very clearly. Yes, so that's it for today. Okay, we will stop it over here. Okay, I don't want to, make it too heavy on you guys because it's just the starting, right? So I'm just trying to keep it as mediocre as possible. Once we enter into our flow, once we start learning a lot of things, then we will slowly catch up the pace and we will try to progress. Okay. So yeah, guys. Any doubts so far? Anything that you want to ask? Even outside whatever I discussed today, anything that you want to ask, you can ask. If there are no doubts, then yes, you can wind up the session. Everything clear? Yes, guys, everything is clear.